Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is the coordinate geometry. Today, we take our second lesson, and in this second lesson, what you're going to learn is how to find the slope or gradient of a line segment. So let's begin. So after completing the lesson today, my dear student, you'll be able to find the slope or gradient of a line segment. This is what I hope you'll be able to do after completing the lesson today. So as usual in our segment, Mercies funded today, I'll give you the second property of Pascal triangle. Like I've said, the Pascal triangle has a lot of amazing and interesting properties. Today, I'll give you the second property, and that will be done after completing my lesson today. So to begin the lesson, let's first learn what is slope or gradient. Slope or gradient of a straight line is nothing but the ratio in the change in the vertical distance to that of the horizontal distance. And slope is given by the simple formula based on this definition. Slope is nothing but the change in the vertical distance divided by the change in the horizontal distance. This is what gives you the slope, and this is the ratio of those two distances. And if we have a straight line that passes through 2 points, and those 2 points has coordinate x1, y1, and the other point has coordinate x2, y2, if the slope of that line is m, as this line now depict or illustrate this statement. See, this is the line, and these are the 2 points of the coordinate x1, y1, and the second point with the coordinate x2, y2. You can see this blue line passes through these 2 points. And if we now complete this right angle triangle, look at the 2 red lines forming the vertical distance and the horizontal distance of that right angle triangle. You can see now the vertical distance is denoted by this y2 minus y1. That is the difference in the y coordinates of the 2 points that the line passes through. And the horizontal distance of that your right angle triangle is denoted by x2 minus x1. And that represented the difference between the x coordinate of the 2 points that the line passes through. So based on this, if we are to find the slope of this line that passes through these 2 points with the coordinate as illustrated here, so the slope m will now be nothing but change in y divided by change in x. This is what we have been using even in our physics and chemistry practicals if we ask to find the slope or gradient. And this change in y is denoted by this y2 minus y1, and the change in x is nothing but x2 minus x1. So substituting there, you now have the slope to be equals to y2 minus y1 divided by x2 minus x1. This is the simple formula that we are going to use to find the slope of any line, provided you have 2 points on that line, and those 2 points you have the coordinates of those 2 points. So this is what you now substitute. In this simple formula, what you have in the end is now the slope of that very line. We are going to take examples how we can make use of this formula to find the slope. So example number 1, it says find the slope of a line that passes through these 2 points. One of the point is this point with this coordinate 2, 6, and the other point is having coordinate 3, minus 1. Solution to our problem. So what we do first is to write down the formula for finding slope, which is m equals to y2 minus y1 divided by x2 minus x1. So there you now let one of this to be x1, y1, and the other point to be x2, y2. Let me do that. So if I let this first point to have coordinate x1, y1, and the second point to have coordinate x2, y2. So I can now replace these variables there. My y2 is nothing but this minus 1. My y1 is nothing but this value 6. And x2 is nothing but 3. And x1 is nothing but this 2. So substituting there, you now have minus 1 minus 6 divided by 3 minus 2. And you now simplify both the numerator and the denominator. My numerator minus 1 minus 6 simply gives a result minus 7. And the 3 minus 2 simply gives 1. And minus 7 divided by 1 will give final result minus 7. So minus 7 is the slope of this very line. Let's just take one more example. Example number 2 says find the slope of a line that passes through these 2 points. One of the points has coordinate minus 2, minus 4. And the other point has coordinate 1 over 2, 1 over 2. Solution to this very problem. So what we do first is to write it down in the formula for your slope, which is m equals to y2 minus y1 divided by x2 minus x1. So you now let one of these points to be x1, y1, and the other point to be x2, y2. So there I have my x1 as minus 2, my y1 as minus 4. Look at it. And this will be x2, and this will now be y2. So substituted in this very formula, you now have 1 over 2. That is your y2. Look at it here. Look at it here. This is your y2. Minus 4. Minus 4 is your y1. Look at it, y1. And this is your y1 from this question. Divided by 1 over 2, your x2 minus 2, which is your x1. So simplifying the denominator, minus always change to plus. Similarly, minus here at the bottom also change to plus. So this in the end, you now have 1 over 2 plus 4, which gives you 4 whole number 1 over 2. And the 1 over 2 plus 2 will give you 2 whole number 1 over 2. I have changed this over to this division sign. So I continue. So next is to change this back to improper fraction. 4 times 2 plus 1, that will give you 9 over 2. Divided by also this change to improper fraction gives you 5 over 2. So there we now change this division to multiplication. You now have 9 over 2 times 2 over 5. You remember this division by fraction means multiplication by the reciprocal of that very fraction. So if I continue this 2 cancel 2, you have 9 over 5, and 9 over 5 reduced to mixed fraction. You have 1 whole number 4 over 5. This will now be the slope of this line also. So with these 2 examples, I have come to the end of this very lesson, my dear students. I hope with these 2 examples, you'll be able to find the slope of any line segment, provided you have coordinates of 2 points on the line. So let me just move and give you something interesting about the Pascal triangle, the second property. So the second property of Pascal triangle, this is your Pascal triangle. This second property says if we are to assign a place value, that is the appropriate place value to each number in a given row, what you have in the end, that number you now have is now a power of 11. Let's just start with the first row. First row, I have just one number here, and this one number is this only what it is having place value unit. So this one is nothing but 1. But moving to the second row, you have 1, 1, 1, 1. So one of the number has place value 10, and the other one has place value unit. So this number will just be 11 after assigning appropriate place value to them. Next row, you have 1, 2, 1. If you are to assign place value, this 100, this times this unit, what you have in the end is 121. Next row is having 1,100 times unit. So in the end, this number is nothing but 1,331. And if we continue like that, you have 14,641 in the fifth row. In the next row, you have 161,051. And this is what you have. So if you go back to this very first number in the first row, there 1 is nothing but 11 raised to the power of 0. This 11 is nothing but 11 to the power of 1. 121 is nothing but 11 to the power of 2. 1,331 is nothing but 11 to the power of 3. If you are to find it, this is what you have in the end. And 14,641 is nothing but 11 to the power of 4. And this is nothing but 11 to the power of 5. This is 11 to the power of 6. So all those numbers, after assigning appropriate place value to them, the number you have in the end is a power of 11. You can do the rest and find out. The next one will eventually be 11 to the power of 7, next 11 to the power of 8, and so on. So this is amazing. This Pascal triangle is very, very interesting. We are going to take another property of this Pascal triangle in our next lesson. Thank you for your attention.